I'm Nathan Rowe, co-founder and editor of Lidar News. You're tuning into a webinar recorded on June 27th, 2025 about bathymetric LiDAR and other hydrographic techniques used in coastal mapping. We're going to switch over to the webinar now where I introduce the panelists. So thanks for joining us and I hope you enjoy. Off with Jose Martinez Diaz, who's the Survey Product Supervisor at Fugro USA Marine Hydrography Group. Jose graduated with a Master's of Engineering in Geomatics and Ocean Mapping from the University of New Brunswick and has a Bachelor's of Science in Oceanography from the Universidad de Baja California. He's worked at Fugro for the last 25 years and has been immersed in bathymetric LiDAR technology and projects since 2005. Jose is a certified hydrographer, credentialed jointly by the National Society of Professional Surveyors and the Hydrographic Society of America.
Kyle
Goodrich. Yeah, thanks for being here, Jose.
Thank you. Yes.
Kyle Goodrich is the president and founder of T-Carta, a global leader in marine remote sensing. With a 24-year career in geospatial, hydrospatial, and hydrographic fields, Kyle is a passionate leader within the ocean mapping community with an extensive background in satellite remote sensing and cartography. Kyle holds a bachelor's degree in geosciences from Williams College. He currently leads the business development for T-Carta and has been the principal investigator on multiple small business innovation research grants from the National Science Foundation and NOAA with a focus on coastal zone mapping innovations.
Thanks, Nathan.
Aryan Moe is a seasoned technical manager at Hatib and Alami, or K&A, with over 19 years of international experience in geomatics and geospatial technologies. Aryan is a leader in topographic and bathymetric mapping, geospatial data analysis, and technology integration. Thanks, Aryan.
Thanks, Nathan.
Yeah, you're welcome. And our moderator, Zan Fredericks, is the Emergency Response Coordinator for the USGS National Geospatial Program and oversees the Bureau's Geospatial Information Response Team. She's the co-chair of the ASPRS Bathymetry Working Group and previously chaired the USGS LiDAR User Group for over 7 years. Zan has previously served as the National Map Liaison for the USGS NGP User Engagement Office and as the LiDAR Coordinator for the USGS Coastal and Marine Hazards and Resources Program. So thank you to all of our panelists and our moderator. Really excited for this conversation and appreciate you taking the time to share your expertise with all of us. So without further ado, I'll hand it over to Zan.
Thank you so much, Nathan. And Sarah, thank you so much for helping to organize us today. Bathymetric LiDAR and beyond. I am very excited. Anyone who knows me, 532, right? Like we love talking LiDAR in our family. Hydrography as well. You're not left out. My husband used to do sonar and I did LiDAR. So the joke was he sonifies and I illuminate. Lots of great nerdy conversations going on at home, I assure you. But our focus today isn't just LiDAR. It's sonar and satellite-derived bathymetry as well. So just quickly, if you're unfamiliar with those terms, LiDAR is like radar, but instead of radio waves, LiDAR is using concentrated pulses of light to map the target. Think of a rangefinder. We'll be discussing bathymetric LiDAR mostly, so the difference between topographic and bathymetric LiDAR is that wavelength. Topographic using a near infrared, bathymetric using that 532 green wavelength. It can penetrate the water column a little bit better and in theory, save enough energy hitting the bottom and returning to the sensor. Now, if you've ever been snorkeling or scuba diving and you're looking down at that kind of brown coral that everybody's warning you about, fire coral, you're like, it's not that exciting. Bring it to the surface. All of a sudden, it's a bright, fiery red. That's because that red laser is getting absorbed by the water column pretty quickly. So the difference, again, between topographic, bathymetric, red, and green. Sonar, again, similar to radar, but using sound waves instead of those radio waves. And if you hear the term multibeam, that's a multibeam echo sounder. It's using lots of beams rather than a single beam to map the target. And finally, satellite-derived bathymetry. Exactly what it sounds like. Driving bathymetry from satellite, you'll hear it often referred to as SDB. So to get us started, Aryan, I'm thinking globally, how are these technologies, all of them are one, how are they being leveraged globally to contribute to a comprehensive coastal mapping strategy?
Yeah, so each has their own strength. So it's not one technology over another. Mainly use SDB for desktop studies because it also offers a cost-effective over large areas, and it's very similar to the results are very similar to the lidar. So you kind of get an overall an idea of what to expect when you're doing your lidar survey. And the multibeam, well, the multibeam is we can be considered the gospel, so uh, it's to be used now either to validate your data and also infill any holes that you might have in your data set. So it's more of a combination of all the technologies rather than one.
I appreciate that. And talking about hydrography, Jose, it seems like you have a vast background with that hydrography. Before you answer it, I think Nathan's got a poll for us. The first one is the level of expertise of our panelists, just so the attendees can get to know kind of where our background is. Would you go ahead and open up that poll, Nathan? Perfect. It's popping up for us. Question for those watching the recording in case the poll doesn't show is, how would you describe your experience with coastal mapping technologies? For instance, bathymetric LiDAR, multibeam, or single satellite-derived bathymetry. And we're doing great. Okay. Lots of attendees answering. Appreciate that. All right. It looks like out of what we've got 17 or 30% saying I've used one or more of these technologies in my work, closely followed by 28% I have some familiarity, but not hands-on experience. And then we've got a tie for third, if you will, I guess fourth, fifth. I'm new to these technologies. I regularly work with multiple coastal mapping systems, and I'm an expert or lead projects involving these technologies. So we've got a great variety. And I like that I've used bathy LiDAR systems, but couldn't get my vote in time. Totally understand that too. Love that we've got additional feedback coming in the chat. But over to you, Jose, specifically about the hydrography. How do you see it being used to really complement and help with that coastal mapping?
Yes, thank you. Well, seeing the poll results, I think we cannot fluff it up too much because we are, people are gonna catch up. But yeah, you're correct. I've been doing hydrography for quite a few years, and not obviously, but as Arian has said, one starts with the more traditional or more robust technology that used to be, the sonar, the multi-beams. That's where you started, and when you do that, obviously you dealing with mostly coastal mapping for charting. You want to go as close to the shoreline as you could to map the shoals that are, the risk for navigation and for mariners in general. So you get as close to the shore as you can. Some areas are very difficult to get in because the risk involved for vessels. So your collections were limited when the technology was also limited on wherever you could go. We're limited about that. But as the lidar bathymetry, or ALB as it is known as well, airborne lidar bathymetry technology, sensors started to pop up in the late 90s from the commercial and institutional point of view. That was a great opportunity mainly for hydrographic offices to start using it, test it, and then use it for actually filling the gap between the multi-beam and the shoreline. And if not that, at least picking up all the shoals, all the bits and pieces that basically mean that you should not go there because it's full of rocks, right? That's what the main point of the charts are. And that took off. For for the profession, and we as as a company doing that, assisting hydrographic offices, well, we were in business in using the technology, right? And also satellite bathymetry, you know, that also came up on the picture because the algorithms and the software became so robust, and the satellite information became so robust that I mean, we couldn't ignore you. We couldn't shy away from actually looking at that information. So yeah, I guess as a progression into why we're using these tools in hydrography is because, you know, we need them all to basically, you know, have the full picture, right?
Absolutely. And I think that's a good overarching view of how the technologies are complementary. Kyle, Jose mentioned satellite-derived bathymetry, especially if you have that white ribbon right between the coastal land and then as you have near seashore. Can you tell us a little bit about how you're seeing the satellite-derived bathymetry really benefiting the LiDAR operations and the other hydrographies?
Yeah, absolutely. And I always, this community talks about, the toolbox for coastal mapping and, kind of all these technologies kind of fitting into the toolbox. And then, applying the right tool to the job is always kind of the task at hand. And satellite drive, each one of these technologies has its own strengths and weaknesses, whether it's, the cost effectiveness or remote production of satellite bathymetry and not putting anybody in the location, or the very, down to the millimeter precision of a multi-beam survey and a boat survey in coastal waters. But, using that right tool for the right job is really kind of the crux of the matter, I think, to be kind of most efficient and developing a kind of a comprehensive coastal strategy. Satellite-derived bathymetry is, by definition, is targeted at that kind of coastal gap because, we can only map to about 20-meter depths, but that is kind of the inherently that white ribbon area that is challenging and risky to survey with a boat. So, looking at an area and saying what the problem set is and understanding if, deploying a people and a boat to a location where there might be unmarked hazards that you have to mow the lawn and go across it to find those hazards isn't really all that great of an idea. And obviously satellites or, airplanes can remove the sensors and the people from that environment of needing to go and potentially run into a hazard while you're trying to map it. And then, satellites remove the people and the sensors, one step further into space. So each kind of method, has its advantages in terms of what you're trying to measure. And, using them in combination to map these coastal areas is really kind of the best comprehensive strategy if you want to think about this kind of holistically.
Well, I think that's a good point because when I first got started into LiDAR, it was interesting for me to realize that it's not a panacea. There were so many different environments and situations where we wouldn't get returns. And it's such a great technology that was kind of hard for me to swallow at first. But, I was excited to see that there were complementary technologies instead of competing technologies. And that was really helpful for me to have a better picture, especially after hazards, looking at what a coastline has changed or become, especially in those dynamic environments. But we've got our first question from our attendees, and that is, what is the most accessible way to collect bathymetric data? And is this different from what you're seeing as the industry standard? Ariane, what are your thoughts on that?
So the most accessible is SDB, right? Because not everybody has a sensor, not everybody has an aircraft, and budget-wise, it's also limiting because it's quite expensive. So, while with me being all LiDAR, I would like to say ALB is the way to go, but no, most accessible is of course SDB.
Fantastic. Jose, what's your take?
Yeah, absolutely. The data, you have actually free data out there from satellites. You could actually get free data from Landsat, for example, and get to understand, at least at the very beginning, the very basic principles of satellite-derived bathymetry. And I think any GIS software can actually take that data and with a little tweaking on the raster calculations, you could actually derive your own bathymetry. Yeah, very economical, but obviously it's limited because the principles are not, the formulas that you might find are not fully developed. That when it comes that the principles of the physics of the actual measurements you want to make and all the considerations you want to make, then, it starts to get complicated. But access-wise, bathymetry via satellite is probably the one that's going to give you at least the first the primer physical characterization of whatever you need to. And it's very important. I think if there are some, managers here that want to do something, at least they have that. And then they say, oh, well, I think it's viable to actually keep looking at this section of seabed coastal area that I think satellite-derived bathymetry did good, but we need to get more, right? And then is when you start budgeting for what's next, right? What's the next technology, or what is my budget that I can use? Maybe go reach to Ticarta, maybe reach to EOMAP, maybe reach to Fugro or KNA to actually, okay, what can you do for us if we need to expand our initial experimentation with the data? Yeah, it's all about getting to know what's there first, and then moving up to the next level.
No, that's
Yeah,
an important take, because
And
that situational awareness. Go ahead, Kyle.
Yeah, and if I could add, I would certainly agree that I think satellite bathymetry is kind of the easiest or most accessible technology within this mapping field. But that's also kind of a blessing and a curse, I would say, because you could say, just about anybody can do it now. And it's true. You can go on and find a research paper, put into ChatGPT, and just about anybody could get stood up on satellite bathymetry within a few days. But there's a certain level of expertise that really needs to be applied in to put this towards a real world environment where it's might not be the perfect conditions of the perfect imagery. So having access to open source imagery and open source software to produce satellite bathymetry doesn't mean it's good high quality data being put out, and that's where the level of expertise really needs to be put onto it. Is I've spent my whole career trying to convince people that satellite-derived bathymetry is a worthy and high quality product, and then it can turn into the whole wild west of, if anybody can do it, that doesn't mean anybody can produce high quality results like that. So the accessibility also has to come alongside with the high level of expertise to be able to interpret the results of that, to know that this is a good result, or this is a bad result, or this is or we should go fly LiDAR because we're not getting good returns here from the satellite bathymetry. So there's a double-edged sword, I guess, with that level of leveling the playing field. And that's certainly something that my company provides in terms of training people to understand that there's a certain kind of skill set to build to understand how you're producing satellite bathymetry and then how to use it within these other technologies. I just want to add that point.
No, and that's a really good point. And I think it applies to all of the technologies we're discussing today, right? Just because you can mobilize and fly an airborne LiDAR sensor does not mean that it's been optically calibrated correctly,
Right.
or that you're collecting accurate data. Just because you can turn on the system and record returns, again, you need that expertise. You need people familiar with how all of the technology is working together, what kind of trajectories you have, how's your IMU impacting it, are you is there drift going on because you're flying too long of a flight line, things like that people new to the technology may not be familiar with. Similarly with sonar, if you're not accounting for those sound velocity issues, right? Like there's so many different impacting caveats that I think it's important to mention those. And I love that you started with satellite-derived bathymetry, but it also kind of turns us towards standards. So Nathan, I believe you have a poll question about some of the common standards that we're seeing being used. And I'd like to see if the attendees would provide us with what technology or what standards they're using or seeing used for these different technologies. So hopefully the poll question has come up for you. For those on the line watching the recording, it's what survey standards do you see most commonly referenced for bathymetric LiDAR data quality control? So this one's specific to LiDAR, as it's the most prevalent with the standards that we've been developing recently. There have been more long-term standards being used for hydrography sonar wise. So LiDAR is the new one. And we've got great responses so far. I figured this could drive the next part of our discussion. All right, looking good. Right now, the ASPRS positional accuracy and the last specification seems to be the most prevalent, followed closely by the IHO S44. That will be your international standard. And then surprisingly, the USGS LiDAR base specification, while topographic specific, seems to be driving that standard following. And then we've got the National Hydrographic Office standards, Interagency Working Group on Ocean and Coastal Mapping. Shout out to Ashley, saw her on the line earlier, and any of the other people that joined. I just happened to see Ashley, and then some others. So the question with the satellite-derived bathymetry, Jose, you mentioned, I thought, a great way of saying it is you use it quickly for situational awareness to assess if you need to then go in with a different platform. The precision of satellite-derived bathymetry, are those oftentimes up to the S44 standard or not so much?
Well, yeah, that's the holy grail of hydrography, is that what data actually can actually fit your minimum accuracy, vertically mostly, how tolerant the survey has to be in order to be able to go into a chart, and because the satellite bathymetry covers the shallow part of the water. That's where the most demanding sometimes requirements are, and obviously is for navigation where boats go, right? Not all the coastal areas are in that position to be transited by small boats, because it's risky, but navigation is important, and that's where the shallow area has to be mapped. And then, of course, as probably Kyle's mentioned, it's all about the expertise and the validation you can put on your result, right? We can easily derive some some measurements of the bathymetry on any area, but how well accurate those measurements would be. These days, when we go up on the LiDAR, for example, somebody said, I want to remember who said that. Probably it was Gary Gunther or Victor Fagel. Some of the big names in bathy LiDAR said, doing bathymetric LiDAR is easy. It's almost a byproduct of the 532 LiDAR wavelength. But doing LiDAR hydrography, that's hard, because now you have to account for tides, you have to account for everything that comes into the final bathymetric solution. So that's hard in the sense that you have to compare your data to something else, right? Either if it's a bathymetric, multibeam sonar, which you would think would be, more robust in terms of measuring, because you're measuring a lot and you can stay stationary at one point and tweak your sensor until you get it right, lower your plate, calibration plate, and you're sure you're measuring the sound velocity accurately. So you think you would do it better with a sonar. Then, okay, let's try to use that for LiDAR. And then let's try to use that for satellite bathymetry. And then why not use some RTK points on the beach? That's how the whole situation goes. And all those are still valid, and all those have to be render you data that meets the standard. And obviously the S54 for hydrographic charting was a standard that most people use in this for the attendees. But obviously the SPRS, because it's LiDAR, and the SPRS is very popular as well. I'm surprised I would like to learn, when the poll says other, what other standards are people using, right? I would like if somebody that the people that actually stated other, I would like to see that on the chat if it's possible, right? I mean, no compromising, no compromise, but I would like to see them, because we are interested to look into all the standards or all the sources of this information that could be used for integrating, what is the next move, right? which there's something brewing in SPRS bathymetry group to implement a new standard, not a new standard, basically something that everybody can actually use as a base, right? So I'll be interesting to see.
I agree. I'm very excited
I
about it.
second that as well. Yeah. Yeah,
And
because
Ariane, from a global perspective, do you rely mostly on S44, or what standards seem to rise to the top do you find yourself mostly adhering to?
Yeah, the IHO standard is kind of the standard that we adhere to, but unlike topography, it's almost like a global standard. Even though the topography has your standards for your imagery, has a standards for your lidar, has a standards for control, and it's very elaborate. And I think it might be it's something that we're lacking. They combined all the technologies, and this is the overall standard that it should adhere to. Even though one technology over another might be able to get better accuracies using multibeam or lidar, but each should have their own standards, and that's I'm hoping that's how it will be in the future.
No, that's a really good point. We did have a question come in about how are we mapping the seafloor, or is the seafloor being mapped with UUVs? Assuming that airborne LiDAR is out. Ariane, can you speak to that at all?
Nope. Sorry.
No, you're fine. That's why we're asking around.
I can add a bit of context there in terms of UUVs. We do work with a few operators around the world, providing some kind of situational awareness or operational information for them for their mission planning. But oftentimes the UUVs are in deeper water, and they're focused on the 200 meters and deeper extent. So I wouldn't necessarily call them, a technology of focus for the coastal mapping community, largely because those UUVs are underwater and can run into hazards just like any other vessel out there. So in order to plan a mission in a coastal environment with UUV, you have to have that detailed coastal data to begin with, in order to not put your equipment at risk of running aground. So I haven't really seen much use of UUVs in coastal mapping specifically. It's been really more focused on the deeper water areas.
Got it. And
Yeah,
Kyle,
I think
how would
yeah.
Go ahead.
No, I think that makes sense. The underwater vehicles, the advantage is that they're close to the bottom, right? And sometimes if you survey deep water from the surface, sometimes your resolution is going to degrade as it goes deeper, right? Doesn't matter which sonar you're using, it's going to create probably result targets probably a little less than that if it were closer to the bottom. So yeah, I think you're right. The UVs probably are better suited to deeper water where you still want to get the resolution. Map things are very deep at the and they still get 1 meter resolution or better. So you have to use those. But obviously using those in shallow water, well, maybe it's overkill. Yeah, it's very too risky for the vehicle itself. Unless it's on the surface, which in the case
Right.
of USVs, right?
Yeah.
Underwater, no, well, whatever, ASVs. So the acronyms are crazy, but we get it, right? It's autonomous vehicles that go above the surface and under the surface, and obviously the ones above the surface are the ones that could be useful for shallow mapping.
Sure. Well, in shallow mapping, and that brings us back to the precision, right? Because the deeper water is a different animal all in itself. Kyle, how do you assess the precision of satellite-derived bathymetry, and what is there kind of a range at which you work, or that you can let people know that the data are, around or seem to meet?
Sure. Yeah, obviously there's the whole precision and accuracy kind of intermingle here. In terms of resolution, we can, map from satellites at 30-meter resolution and 10-meter resolution from publicly available imagery, and then down to 2-meter, 1-meter, and even sub-meter resolution using commercial satellite imagery, depending on the approach. So in terms of precision, we can end up getting, multiple measurements per square meter from a satellite. And then obviously the advantage of a satellite is we can also potentially process multiple images in a stack. So you're effectively getting even more measurements per square meter to help with that precision and accuracy, because we can kind of, measure 12 times and average to a single measurement and get a very more accurate and precise measurement there. So the precision is very, dependent on what sensor and what approach you're going to apply, using satellite bathymetry. And we, either validate that or using either a secondary space-based instrument. The ISAT-2 sensor has been a really instrumental satellite for validation of these other satellite-derived bathymetry methods, but even that has limitations. So quite often, if you're really wanting to get the most validated and precise satellite bathymetry, we would often use a single beam data from a single beam sensor or LiDAR if it's collected at coincident times, because obviously we're operating in a dynamic coastal environment. So a LiDAR collection from 3 years ago compared to a satellite bathymetry of today, like there might be differences that are just due to change, not necessarily due to accuracy or precision issues. So sometimes it's a bit of a challenge to get to that exact, comparison of LiDAR precision to satellite precision or single beam to that. But we kind of do our best, to kind of approximate, and that's where actually those unmanned surface vessels often come in quite handy, because those can go into those shallow water areas, collect very precise single beam points, for example, and those can really be used to validate and calibrate the satellite bathymetry to get a more precise product. So when you start combining these sensors in different ways, that's how you can really kind of up the level of each one of them to get more precise and accurate data, I'd say.
That's really exciting, and I think that's a great example of how well they do complement each other. Ariane, do you have any examples of a real world project where integrating these technologies has helped that outcome?
Oh, my current project, no, but I'll drag Jose into this. I think Florida, the project that Fugro is currently doing in Florida, is a great example of the combination of the multi-beam desktop studies with SDB, with lidar, and even the topo lidar as well to generate this immense data set to be used by a variety of government agencies.
Jose, do you want
Yeah,
to?
I guess I can second that, as Arian mentioned it. Yes, and these large scale projects, mapping the Florida coastline, obviously are, you want to be as efficient and productive as possible, with all your technologies being very, fine-tuned and sharp. So you get all these comparison and validations on a not quickly and rapid. Well, obviously that's a must these days. Do everything quick and fast, right? But it's because the volume of data that you're collecting every day and the volume you have to collect the next day, you have to have some ability to process data and to validate it to each other. Like, we start with we could have started with satellite-derived bathymetry, just to get where is the difficult points in time for doing a survey in around Florida, right? And if we didn't start with satellite bathymetry, we did start with something else that the satellites can provide, which is quality, water quality indicators, like the same satellites that can provide the bathymetry can provide quality indicators, like how the light attenuates with depth, and how the bottom can respond to not just passive energies like the sunlight and emitting back to the satellite, but to the lidar data, which is more on an active sensor shooting the energy and coming something back. So all that data that was used for planning a large survey with lidar, used satellite, not for bathymetry, but for measuring everything else, right? Measuring water quality, measuring turbidity, measuring bottom type. So those were used for that. And obviously you have to have procedures that the people revising the data have the means to do it quickly and pass it on to the lead hydrographer or the chief or the senior surveyor doing the assessment of how good the data is, right? And Arian mentioned, you go from topo lidar to bathy lidar to multibeam, and you have to have a combination of skills, software, standards, and as going back to a little bit, if I may, on the standards. Obviously, topographic LiDAR is more widely used for because we live on land, right? So it's more widely used, it's more precise, it has more density, and most of the specs, USGS, for example, and SPRS are built on top of the bathy topographic LiDAR. But when these technologies go, when LiDAR standards go into the water, the whole thing changes, right? We cannot, we would like the data to be as accurate, as precise, as dense, as everything. But the environment does not allow it, right? Just going from air to water and everything is in the water is very difficult. So the idea that we want to harmonize standards into one is very difficult. But what we want people to understand is you go with the topo lidar all the way to the water line, the water edge, and you measure and you compare that to your USGS standard, get it done right. From the water and down, okay, well, have to probably stand back, look at the hydrographic specifications, the standard H44, and what other agencies, for example, NOAA or Army Corps of Engineers, have done to actually try to merge the two worlds together, right? So you can use those standards in some way that you're not measuring just on-air measurements on land, but you're measuring things in water, and you have to account for the errors that come with that, right? You still want the highest precision, highest accuracy, but obviously it's not going to be the same. So that's the importance. The point part of I want to make is just that yes, these technologies are good, but everyone is based on its own and has to be accounted to their appropriate level, right?
Absolutely.
Yeah, but I would say, those standards would have to be elaborated on. And I think that's kind of, I might be an unpopular statement, but I think that's what we're kind of lacking at the moment is that, okay, like you said, we know everything about topography. It's easy to check and everything, but those standards should include, okay, if you're going to provide SDB, it should meet these accuracies, and it should have been the accuracy statement should adhere to these procedures, and same with multibeam and same with lidar. I mean, the three technologies, they're widely accepted as legit, and it's not black magic. It's legit technologies, and I think the standards right now kind of have to catch up with those technologies and provide some sort of procedure or breakdown or something that I could say, yeah, my bathymetric lidar meets this specification, and it meets this specification because I adhere to this procedure for checking.
No, that's a really good point, Ariane. And to me, I was very excited the Interagency Working Group on Ocean and Coastal Mapping leveraged lots of expertise across different agencies to compile the Standard Ocean Mapping Protocol, the SOMP, and that was recently released. And I think that is a great way, a great place to start looking at best practices and things to adhere to. But Jose, where should we be looking for other best practices for bathymetric LiDAR specifications?
Well, that's a very good question. Obviously, IHS very good, but as you mentioned it, there is this effort, at least from what I can tell, is that the intergovernment documents that are coming up, I think will be very important to spread those as make it very popular. Let's say that would be the challenge. How we can communicate these documents that obviously reside in some agency, organization, website, and for IHO it's taking years to make these documents public, right? And they have periodical reviews, and because the hydrographic IHO is a international organization, obviously it has many eyes looking from different places, right? Well, the same has to happen. I know the U.S. is taking lead on trying to publish, because this is information that goes anybody in the world can access, right? So there's a value on the what the U.S. is doing, but it will be nice to if see if the people in Germany, people in Australia are, I'm sure they have their own say about it, right? I think on the poll there was what the Australian Hydrographic Office is doing for their own work and what can they share to others about it, right? So it's about how we disseminate the information, the methods, and the validation that everybody's happy, or at least people will agree. Okay, that's very that's fair. And in that regard, I was thinking also on SDB. SDB has obviously has to match whatever standard out there is now, right? The IHO and Lidar, and okay, but probably will be a good question for Kyle. Is like, do you see, Kyle, a standard is made for SDB out there? Put it out there for benefiting your customers, for example. Just look at this, and your data has to match this, right?
Yeah, that would be hugely helpful, and that's actually kind of a major missing piece to this whole discussion, I think. And I appreciate you bringing up the SOMP that was published by NOAA, because that actually completely left out satellite-derived bathymetry from the standard ocean mapping procedures, not mentioned in there at all. And that's something that
Being
is
revised.
being revised, yeah, but it's a kind of long time coming in that, and the satellite bathymetry, as Arian said, has been a very proven and established method. It's used internationally quite a lot, but it's actually not used that much in the United States, like that, and it's been a missing gap that industry has been waving their arms, saying like we need this in order to kind of ratchet down what is the kind of Wild West out there if anybody can do satellite bathymetry, and there are no standards out there. And we know that NOAA is using satellite-derived bathymetry for multi-beam survey planning and other uses, but it's not being published or being part of the standard ocean mapping procedures. And I think that's where a missing part of this whole community being truly integrated is some leadership from those standards perspectives, because there's best practices guides, there's other kind of things out there, but satellite bathymetry is kind of the black sheep of this industry here. It doesn't really fit into the hydrographic world. There's nothing in the ASPRS about it. It's somewhere between satellite remote sensing and hydrography. It is kind of truly that hydrospatial product that is kind of blending information from remote sensing as well as hydrographic practices. But there are no standards out there. Many public tenders that come out say that the satellite-derived bathymetry products should be built to industry standards. And those are just, we make those up. TCARTA has our own standards, and then everyone's happy. I'm very welcome everybody use our standards. They're great. We've been developing them for almost 20 years now, but I'm not a standards organization. I can, provide information and guidance to that, but there's been a real lack of interchange between those agencies creating those standards and the industry, because the industry is, there's a couple of providers out here, satellite-derived bathymetry, TCARTA and EOMAP, that are really leading the charge on this, and the government side and the standard side is really lagging far behind in this. And satellite-derived bathymetry is actually 50 years old this year. 1975 was the first time satellite bathymetry was produced by Jacques Cousteau and NASA. And
Yeah.
50 years later, it's two careers worth of work. We're still in the place of like I would push back on it. It is seen as black magic within some fields and like that. We've tried very hard to make this to prove the science and prove where it works and where it doesn't work and where it should be used and where it shouldn't be used. But it's still depending on the community. I bet you if you put a poll out there, there's a lot of misunderstanding around satellite-derived bathymetry, and that's a real gap within the hydrographic community for wider adoption of this highly cost-effective and easy to deploy tool. There's a huge gap there that has kind of held it back. And that's something I plead to the ASPRS. I plead to the hydrographic communities, the SOMP, and all the others. So like that's a missing piece to this coastal mapping community.
Right. And you're talking missing pieces, challenges, limitations. Nathan, we have a poll about what factors limit coastal mapping. Let's throw that one up and get into the discussion about what are the limitations, right? How do you choose which technologies? So the poll up right now, what do you see as the limiting factor in coastal mapping today? And we'll wait for those responses. As we're waiting for that, I do want to say, when talking about best practices, especially specific to bathymetric LiDAR, encourage anyone out there to join or dial into the ASPRS bathymetry working group, mostly focused on LiDAR, but not limited to. It's a free group to join. You just need an email address. Nicholas Johnson is doing a great job leading the charge to have frequent conversations and try and get a group together across the realm of hydrography and bathymetry to really capture best practices, not just from a government or academia or NGO or industry standpoint, but something that we can all contribute to and agree upon. So I encourage you to dial in, join that group. We're still at the beginning of our charge, so things are being formulated, but we did create a Bathy wiki page, right, where we hope to capture some of these things. Looks like we've got some great responses coming in on the limiting factor in coastal mapping poll. Right now, predominantly, budgets are the limiting factor. Again, it is much more expensive to map the seafloor than it is the land. You've heard some of the reasoning. Ship time is very expensive, and imagine yourself in a shallow environment where your swath width is limited because you're in that shallow environment, and you have to do tighter lines to get that full coverage. Deeper offshore, definitely more cost effective. The next highest will be our technical and sensor limitations, followed closely by the projects awarded on the lowest price and not the best value or the technical approach. That's a great example of a limitation. Also, siloed approaches, lack of an integrated technology solutions, and also not enough people to do the work. I definitely do think that there is a limitation. Lots of people out there are familiar with the topographic efforts and a bit fewer. I remember coming into bathymetric LiDAR, and I think when they first asked me if I was, willing to post-process bathymetric LiDAR, I think I said, God bless you, because I thought they'd sneezed. It was a term I'd never even heard before. So it's definitely one of those that we're growing. I definitely see us growing, but we started out with few of us. So thank you for those poll responses. And Ariane, what are some of the current limitations that you see to bathymetric LiDAR specifically, and how can multibeam or satellite-derived bathymetry help fill those gaps? What if it's highly turbid or complex environment?
Yeah, turbidity is a LiDAR killer. I mean, it takes so much planning. You can't just go up and start collecting like you do on the topo. There's so much background, time of year, the actual currents, the state of the winds, the tides, whether it rained 2 days ago and all the runoff is just pouring into the water. There's just so much planning that goes on, and the rate of acquisition is that much slower because of it. And I think that's one of the limiting factors as well.
No, that's a really good point. And Kyle, I was wondering, what is the missing element in coastal mapping to make it more operationally efficient and cost effective? We were mentioning some of those limitations, and budget was number one.
Yeah, and that's I'm surprising that budget's always number one. We always talk about budget constraints, and LiDAR is not cheap to fly, and satellite bathymetry is quite inexpensive in comparison, about 10% of the cost typically, and yet it's not often called for in those task orders from those. And often we're looking at very specific requirements that are being driven by a sensor rather than driven by the outcome that the mapping project is trying to achieve. Oftentimes I see a LiDAR project where, you know, they might be flying and it require 12 or 15 points per square meter, but their final product that they're delivering is a 1 meter or 2 meter resolution bathymetry grid. And, you know, sometimes in those cases are not, I would say, argue that we're not necessarily using the right sensor for the job and those, you know, to get the most cost effective solution. Whereas I mentioned earlier, satellite bathymetry can produce data at higher than 1 meter resolution under the right scenario. So if you look at it from like, what is the overarching goal of a coastal mapping project, whether it's that coastal modeling, erosion, you know, monitoring the coastline for erosion, or is this safety of navigation? You know, depending on the application applied, you should be using an appropriate sensor. You know, if you're worried about safety of navigation under keel clearance of down to the centimeter, like I'd never suggest satellite-derived bathymetry, regardless of the location. But if you're looking at an area where it's highly turbid, the challenge, you know, it's a very expensive or far distance to mobilize people or equipment or fly an aircraft to, and you're only looking for a coastal model for a tsunami inundation, satellite bathymetry is actually perfect for that. But you know, oftentimes the specifications are written for a sensor to go fly an area, as opposed to looking at what is the data and the outcome that the project needs, and how is that going to benefit the community that it's going to be applied for. You know, if you're looking at storm inundation and that, then you know, maybe a 1 meter, 2 meter resolution grid is perfectly fine, and it doesn't need to be to that IHO Water 1A standard like that. And you can have a huge cost savings like that and be able to map an entire country as opposed to just one location like that. And I think you can make your dollars and your budget, if it's obviously budget constrained is our biggest concern, you can make your budget go farther if you use the right sensor for the right job to get the outcome that you're trying to achieve.
Well, that's a really good point. And Nathan, I think we have one last poll that would be fit in beautifully here. And it's the idea about what factor is really affecting people's selection of which bathymetric technique they're using. We've kind of touched on a few of them here, right? Is it the safety? Is it the environment? Is it the budget? So the poll should be up now. What factor drives your selection of bathymetric mapping technology the most? Is it accuracy? Is it cost effectiveness? The coverage area that you need to, right? Is it a full coverage or is more sparse coverage fine and you can interpolate it, right? You were mentioning, Kyle, what are you trying to map? I think that's always a good question. And also the speed of data acquisition and emergency response, for example.
Yeah.
We need that data turned around very quickly. And sometimes you don't want to be waiting on precision trajectories, right, for that airborne LiDAR. And we've definitely, in response, have used the ultra or the rapid, knowing that it's a balloon animal, right? You squeeze on one side to get it quickly, and then another side kind of expands, and it's that three-legged stool. You can't have it all. You've got to decide. So as we get the poll question, the answers coming in, it looks like the first and foremost is that accuracy. That's the most important factor selecting what kind of bathymetric mapping is going to be going on. Tied for second is the cost effectiveness and also the area coverage. And then coming in the speed of data acquisition. So again, that kind of shows you that if we're trying to map large areas for, say, baseline mapping or potentially, you know, just a benchmark, you know, following up year to year temporal window into the environment that's coming in. Now, Jose, I wondered, how would you go about, what factors do you consider when you're trying to choose in between those different technologies?
Yeah, well, as maybe using the poll results as a baseline for my response, yeah, I think it depends on the application. You just mentioned the emergency response, like you need to go up there, do it quick, try to do it accurately. The cost effective, well, fortunately, there are some budgets that allow you to do it quickly with, mobilizing quickly at whatever cost, right? Obviously, that's good. And obviously, I would say it's sacrificing, I don't think sacrificing, but obviously the budgets are a little less constrained than when you will see a public tender for mapping anywhere, right? And the thing that obviously most commonly comes up is the size of the project and who is actually trying to get that done. Most likely is either national organizations like the geological mappings, the hydrographic mappings, the states, right? Like Florida, in the case of Florida or California, those are the ones that drive the the publication of these public tenders, and they actually gonna look for not only cost, right? They're gonna obviously that's very important, but they're gonna look how good your experience has been, however your track record has been, what in your technical proposal, what you're gonna actually deliver to them, right? In terms of how and obviously you could argue that everybody's going to converge to the same deliverables, point clouds, DMs, contours, things like that. Okay, that's good. That's what we asked for. But how you get there, right? What's your procedures? Basically, show us your roadmaps to get there. And obviously, that's something that sometimes it's up to the expertise and the organization to provide, basically, you know, using all your resources, the professional resources you have to bring up this solution. If the thing is, if whoever is looking for to do a bathymetric project, which is more modest in size, maybe just because there's a real estate development on the coast, as a private entity, they have a different approach to what they want delivered, right? Maybe they don't look into hydrographic nothing. They just want the seabed mapped because they want to put, they want to see how the tourism is gonna be enjoy the location, right? Obviously, maybe there you don't need, obviously you would like to use probably a small ASB that will probably single beam may be sufficient. Or if they go fancy, they could actually probably get a UAV capable with the small bathymetric LiDAR sensors that at least there are a few out there now that you can carry on the back of your truck, show on the place and carry on a small survey, right? This is for a small service because
Or
you cannot
STV.
go. There you go. I mean, you could do SUV, right? I mean, at this point, it's just what do you want, and how do you want it? It's variable per project, and obviously, as we as providers of those services, we have a niche of what we can do for the customers that we are targeting to. There might be situations where the the people smaller projects that are more like the one that I described. Maybe there would be a smaller company, a smaller initiative. I can do that. I don't need to spend a lot of money just to get something going, like bring sensors together with expertise and try to bring up bathymetry to the masses, right? Or, starting one piece at a time. And now obviously there is the larger customers that obviously, that's where our role is to provide cost effectiveness, accuracy, and at the end of the day, a product that they can actually publish because it becomes a benefit for the public, right? So there's a lot of goes into that.
No, that's a really good point. And that brings us around, right? We've talked about the current landscape, we've talked about challenges and limitations. So let's talk about looking ahead. Ariane, with advances in AI, that's a popular term recently, in sensor fusion, how do you see the future of integrated bathymetric mapping evolving, especially the roles of LiDAR, multibeam, and satellite-derived bathymetry?
Yeah, I mean, all the industry leaders, Regal, Optech, and all those, they've gone ahead and integrated imagery with, the green laser, the red laser. So that integration has taken place or is on its way forward. I do think AI or rather machine learning or image recognition, I think that is the way forward, but mainly for consistency. Right now, you collect this and you got all these individuals killing dots on the screen, but one person might, interpret the seabed this way, and the other person might interpret it another way, and all of a sudden you put it together, and all the edges don't match, and so on. And I think if you can take, you're not going to take it all, but if you can take some of that, human interaction, if you can take that away and provide, a mathematically calculated, result, I think that it's going to result in a more accurate data set. And I think, yes, you're saving time, but I think that's where the major gains is going to get to it. And because you're saving time, with my time with Fugro, we integrated machine learning, and we were able to process things quite quickly and come to to like an 80% product. And that on the operational side, that allows you to have a more of an educated understanding of what you're collecting, what you're not collecting. Should you collect there tomorrow, or should you go somewhere else? I think just that allows that quick look at the data and to make plans accordingly. But yeah, I definitely think machine learning is the way forward. I don't think there's much more sensor integration that can take place. Yeah, maybe you can make it smaller, and you can get UAVs involved and such. But especially where I'm at right now, it's already a challenge trying to get flight permits. I can't imagine getting a flight permit using an unmanned. It's just not going to happen. We're not there yet. So I think the focus, and I see it in the market. I think the focus is machine learning, and I think that will be the way forward for a little bit.
And Kyle, will machine learning also provide the same benefit to SDB, do you think?
Yeah, I mean, it certainly has already to a large extent. And again, it kind of depends on how you dissect out what we're calling SDB, or how it can facilitate LiDAR operations. We use AI and machine learning for SDB derivations to produce a bathymetric surface. But in terms of the efficiencies and trying to, support LiDAR collection, we also provide, and Jose kind of mentioned this, how satellites, can be used to detect water quality, which can help inform whether good times to fly LiDAR operations. And that's something that we're developing in terms of developing, and everyone wants predictive information, what the future is going to look like. And it's very easy to look at historical information, water quality trends, precipitation trends, wind trends, to see what the water quality is and what that is. But everyone wants, nowcasting or forecasting of that information. And I think that's where AI, I think, can really lend a hand, because you're looking at, massive amounts of information and looking at historical trends and disseminating that into, like, okay, when this happens in this environment, it creates a good condition, for LiDAR operations. Then you can start looking at today's conditions and seeing when that might predict out a good time or bad times to fly in the future. And that's something that, an expert could do, pouring through satellite imagery, flipping through, looking at conditions, looking at precipitation or river runoff, and looking at all this massive amount of information to try to make some predictive elements of when this might be a good time to fly. But that's where AI could really, pour through the entire, historical information quickly and provide that, potentially more predictive based on real world measurements. So that's where I see it going, is really the kind of facilitator in efficiencies of operations, not necessarily replacing killing dots. It does do that, to a certain extent, but we're also in a hydrographic community that still, really highly values, expertise looking at interpreting the data. So I think, using it to get to that 80% solution, so that we're being more efficient with our resources
Right.
and people to kill off the dots, that's a great use of it, and that's where it will go. But I really think it can be helpful in kind of like determining when the best time to fly airplanes for bathy LiDAR collection. That's a real potential there.
That's a good point. And Jose, by far, sonar data is the most immense, I will say. I thought our full waveform LiDAR data was big until I started digging into multibeam files. Do you see similar benefits from machine learning AI with the sonar as well?
Well, there has to be, right? Because what we want to do is just extract more information, maybe faster, maybe more accurate, maybe more predictable, like Kyle said. So I'm sure, or in real time, as I'm collecting the data, in real time, there's already some machine just probably spitting out the results, right there. And the only way to actually to a point that is deliverable for the client, maybe, right? And the only way is basically just put in some I'm gonna say intelligence, but no, the intelligence is on the person that actually coded how to do that solution, right? But let's put it less machine learning, just something that speeds up the acquisition into a product that is already, can be put on a chart or can be used to plan the next thing on a cable survey, for example. And that's very common, right? These days, well, or has been forever on cable of surveys that actually are used for cable laying across the oceans, right? They have to know in real time almost what is the route telling them, what the seabed is telling them on the subsurface about where they plan to lay a cable. And if they don't like it because the data is not very good, they have to know it right away because they have to know then turn back and plan another route. So imagine the ability to get the most accurate results that way in almost real time, and then having the power of decision on the spot, right? So you save a lot of headaches for the final installation, and obviously the insurance companies will be more happier, and we will having these conversations, with less interruptions, right? So that's the whole cascade of events based on a twist on your coding or your procedure, your software, and the technologies that you can bring over, right? And as Carl said, for LiDAR, which is bathymetric LiDAR, which is a niche industry, right? The idea of integrating AI and machine learning using satellite data, having weather data, having oceanographic data, so you can predict what is going to be tomorrow, and if you're able to fly tomorrow and collect good data, or you better stay stay at bed, have a coffee, and don't worry about wasting time, because it's going to be better the next day and not tomorrow, right? So that would be a beauty. So I encourage our listeners, if they want to do something, go into try the integration of massive data sets. And I mean massive, right? Or at least real time. Weather, ocean, satellite, you name it. You go for it. I encourage you to look for those, especially the younger people that are more invested on those technologies.
Yes, thankfully, we do have lots of early career professionals and students coming in with much, much more technical knowledge than I'll ever
Right.
have. And I really appreciate that. It's great that they're bringing those resources and their expertise in that aspect into, the on the ground, in the field expertise that the people have been around longer doing it. I wanted to take this time to switch over to question and answer as we're coming to the end of our webinar. We've got a few open right now, but please, I encourage you, if any questions have occurred to you during this, to be sure to enter them into the Q&A at this point. If we don't get to them today, we do have the ability of having our panelists respond to them at some point offline, so don't be shy. I wanted first to ask Ariane, especially from a bathymetric LiDAR standpoint, we have someone online saying they're a drone pilot focused on coastal mapping, interested in shallow water bathymetry. They're considering a UAS bathy LiDAR system, but they're hesitant to pull the trigger because it's a new and expensive technology, and the success is still being documented. Someone has to take the first steps, though, so they wondered if you could speak to the knowledge of the UAS-based bathy LiDAR system. Have you heard any success stories, if so?
Yeah, I mean, so the technology is the same, but the rate of acquisition might be slightly different. But then, okay, the operating cost is different as well. So I think, project specific. I think it's a technology that can be deployed successfully, but yeah, it would truly be on a project specific. So the larger sites, it'd be just the cost effectiveness would completely disappear. So it would truly be what your market is and what your intentions are. The national wide programs that would be off the books for such technology. So it would truly be, you'd have to look at what your client market is. But I mean,
Fantastic.
the technology is definitely there. I do believe so.
Sure. And the follow-up was that they are focused on very local projects. So that need to fly, say, low and slow to get the density required to map a specific
Yep.
size of feature. I think it could work in that instance for sure.
Yeah, no, definitely. They would have the same problems we do. The penetration through the water column. It probably has a little bit less power, so it would be more susceptible to interference in the water column. But then you can go lower, you can go slower, so you might be able to make up for that. So yes, if it's the small local projects that you're trying to gain, definitely it's a technology that should be considered.
And a quick follow-up question, what's the typical depth range have you been seeing from UAS LiDAR systems?
Yeah, it depends. I mean, I've seen 20-25 meters. It's
Right, it's always environment specific. Do you have a
Yep.
bright sandy bottom that reflects the energy well? All those things.
That's the benefit of bathymetry, is that you can have excuses for everything, right? Oh, that day it just must not have been clear.
Must not have been, I guess.
Right? We'll try it again next time.
You're on to something on that one. How many reflights is it going to take to capture that?
Yeah.
My goodness.
Yeah, but it's jokingly, but like when you're costing projects 30% reflights, it's typical, right? So
absolutely.
Yeah, we're joking about it, but it's definitely something that you have to consider.
Right.
Yeah.
There's a reason we're joking about it.
Right? Yeah, I haven't seen a specification asking for, what if we go out of do a bathy LiDAR survey, and obviously maybe we're not going to get 100%. We're going to have gaps. Why not use some of that budget and try to fill it in with satellite bathymetry? The chances that we could get a good day are probably more are larger than a good day for LiDAR, where you're just probably wasting time with an expensive equipment, waiting for the day that it comes better, right? And maybe that will happen a month later, which is already too much. But if some of those budgets for coastal mapping, LiDAR coastal mapping or multibeam, would be allocated, Kyle will be happy to hear that, but we will do, right? To make it, to fill the gaps with satellite bathymetry, and you can validate that with whatever other data you have. I would like to see some of that coming up for agencies that think about it, right? Instead of having a budget for reflights on more expensive LiDAR or multibeam, let's have it small chunk for filling satellite bathymetry and accept that data as a filler, right? Maybe it's better than nothing, and that's I'll leave it there.
Yeah, you're speaking my language there, Jose, on that one. I think that's definitely a gap that, in the Florida coastal mapping project, for example, satellite bathymetry wasn't even considered throughout that entire lifespan of that project, whereas it could very easily be used to establish a baseline to build all that high resolution LiDAR on top of, as well as fill in the gaps that were inevitable in LiDAR collection, because satellite bathymetry has that advantage of satellites are collecting every single day. So you don't have to get lucky. You just have to wait for an image to come along that has good conditions. And so many times satellite bathymetry is seen as an afterthought. After a project's done, it's like, oh, we should have used satellite bathymetry. And I think it really needs to be flipped around. It should be like, if you're going to deploy people out to the field, that costs money. There's risk. There's mobilization. Like, why not spend pennies on the dollar to have a baseline ahead of time? Because then okay, if we can do better than that, we're doing great. And then you already have your gaps filled before you even start like that. So I think that there's looking at the problem set in a different way. I think you could unlock a lot different efficiencies of operations.
But I think that's where the elaboration on the standards come into play, because there should be a standard in place that allows for the integration of the multiple different kind of technologies. And right now, uh, you know, I can't provide you any accuracy statements because I've combined all these different technologies. But if it's spelled out in the standards, internationally recognized standards, I think it would help us in the industry.
Oh yeah.
That's a really good point. Well, in the time we have left, if you'd each take 1 minute or less, I want to end with this question because I think it's a great way to lean forward and look into the future. We saw that one of the limiting factors was having not enough people to do the work. And the question is, are you aware of any citizen science projects
Yeah.
currently in coastal mapping, whether it's bathymetric survey, data processing, anything? And if it's not just coastal mapping, but also rivers, lakes, seas, anything, 1 minute or less, what's each of your takes on that?
I'll jump in to start. The IHO has a crowdsourced bathymetry project going on that is encouraging citizen scientists to put data loggers on their vessels so that they're collecting single beam data underway, and that's that's data is being aggregated and being kind of put into the Seabed 2030 and the JEPCO kind of global grid, and it is encouraging these kind of recreational boaters, industry boaters, other vessels, non-survey vessels to, take part in this, because they often, these vessels are going places where, other vessels are going as well. And they're often areas that are not of focus for coastal mapping because they're not, industrial shipping channels or such. They're local fishing areas. But that is a way that citizens can absolutely get involved in collecting data and contributing it to the community. And then I'd also add that there's open source satellite-derived bathymetry platforms out there and papers. There's a lot that can be done there. We have a sponsored training program that people can participate in. That's something that we've done actually in East Africa. We're starting a training program in Kenya this fall where people can apply to learn these skills from the community. So there are places out there to get involved and engaged. So yeah, reach out if you'd like to know more.
I love that.
Yes.
Jose, any suggestions or other citizen science projects you're aware of?
Well, I mean, what Kyle mentioned is obviously the one that I would come to mind, and he always he also was a step ahead with with these offerings of open source, open satellite bathymetry. The LiDAR would be a little more difficult, but you know what?
Yeah.
We agencies, especially in the US, they collect a lot of data, LiDAR recurrently in the coastline, and that data lives in digital warehouses where it lives there for a purpose, and the purpose would be giving them an application, right? So I would encourage people to look for data we already collected, we as a community, that lives on these portals that are this most likely if you live in northwestern Michigan. I'm sure there's and you're trying to build up or reconstruct your dock that was demolished by ice. I'm sure there's data there that can help you, right? You probably don't need to well, sorry, but you probably don't need to contract us to do that work if you first go and check what data is there.
No,
And
that's always
obviously
a
we can
good piece of advice.
fill in the blanks. We can
Yep.
fill in the holes, but you can
Absolutely.
always go there and look for data that is already there. It's almost free for you, right? You already paid for it. So
Well, and
go
from a
there and
bathymetric
look for the data.
standpoint, I'm with you.
Yes.
Be sure to check out the U.S. Interagency Elevation Inventory. Click on that bathymetric LiDAR or the hydrography, right? That data sets are brilliant. They point to the national map for the USGS and the 3-depth LiDAR, any of the inland bathymetry LiDAR available. Ariane, any crowdsourced projects that you're aware of that you could
So
suggest?
no, it's a little less in my current though. It's a little less crowdsourced, but the center of GIS in Qatar is the Geospatial Authority of the entire country, and what their national mapping program, what they're working towards, collecting at once, and then provided through portals and such for all government agencies to be able to access that. So less crowdsourced, but it's definitely this repository of geospatial data for anybody to use as long as they're a government agency.
And that's the beauty of it, right? Let's map it once and use it many times. I've always
Yeah,
loved
that too.
that
Yeah.
slogan. It resonates so much with me. Let's not waste resources, especially in times like these. They're so very precious. Well, thank you both to our attendees and to our panelists. Nathan, I'll hand it back to you. What a great talk.
Yeah, that was amazing. Thank you, everybody, for attending, and thank you to our panelists. I will just really quickly, I'm going to put up a last poll, which is just to have you put a couple words in. I'll launch that now. We're going to create a word cloud. Let's see here. Oh, 1 second. It's being shared in the meeting. Interesting. I'm seeing a little issue. We might have to skip that poll question, but no worries there. So anyways, yeah, I just want to thank everybody. I will go through and thank each of our panelists who I really appreciate the time that you took to share your knowledge. And that was an amazing discussion. I'm really excited with how that went. So Jose Martinez Diaz, Survey Products Supervisor at Fugro USA Marine. Thank you very much. Kyle Goodrich, the president and founder of T-Carta. Thank you, Kyle.
Oh, you're welcome. It's my pleasure.
Yeah, and Aryan Moi, technical manager at Hatib and Alami. Thank you, Aryan.
Thank you.
And our moderator, Zan Fredericks. You did a great job, and I really appreciate you getting us through that conversation and integrating all those questions. It was amazing.
Fantastic. I love LiDAR. People that know, I could talk about it all day. So thank you for giving me the opportunity to connect with everyone today. And what a great audience. We had some great questions coming in. Thank you guys for attending. Fantastic engagement.
Absolutely. Yeah, I saw we hit 97 participants at one point, which is amazing. And as I mentioned, we are recording, so this will go up on YouTube and it will be emailed out to those who weren't able to attend as well. And as we kind of wrap up, I'm just going to share my screen. I have here a little QR code that you can scan, and that'll bring you to the Lidar News link tree, and you can just engage in whatever platform you want. You can subscribe to our email. You can reach us on LinkedIn. We're on X and Facebook and things like that. So reach out however works best for you. And I'll let that be there for just a couple more seconds, and then I'll switch to the contact info for our panelists and moderator in case you have a specific question for any of them. You can reach out to them directly. All right, so here is our contact information for our panelists, and then both Sarah and I on the bottom if you want to reach out to Lidar News. If you have any ideas for other webinars, or you'd like to be a panelist for a webinar, anything like that, different content, reach out to us. We're always excited to hear from our audience and get an idea of what you're thinking about and try to best meet your needs. So with that, thank you, everybody. We're really excited about how this went, and keep an eye out for future webinars. And we'd love to see you at another event like this soon.
Wonderful. Thanks so much for your time.
Thank you, everyone.
Take care.
All right. Bye.